All right, welcome back. Hononegah, Honors Algebra 2. So today is the second day of 9-5. So the second day of 9-5, we're actually going to do some phase shift up and down or left and right. So that adding or subtracting a value with the x shifts the middle of the graph. And then adding a value, again, changes the midline. So this is the same as when we did sine and cosine. Okay, this is a phase shift. The h value is a phase shift. So where the middle of the graph is going to be located shifts depending on that number. And then the k value shifts the midline. So just like before, the midline is adjusted if you add or subtract something to the end. And then the a value, that affects the amplitude or how high and how low the graph goes. And b, this affects the period length. So period length. All this is describing, again, things that we've talked about previously. The adding, or this is a phase shift, and this is a change in the midline. So this is the characteristics when graphing. So here we go. Let's go through this all one more time. First, draw in a midline. Second, number in the middle. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. Because there's something being added or subtracted with x, that changes the middle of the graph. The middle of the graph is located, in this case, at negative pi over 4, because that's a shift to the left, pi over 4. The period length for tangent is pi, and so then pi divided by 3. So the period length for tangent and cotangent is pi, and the period length for sine, cosine, secant, and cosecant is 2 pi. The intervals then, instead of dividing by 4, you're going to take the period length and divide by 2. So that in this case, pi over 6 is what I'm going to add and subtract each time. This is not a very friendly adding. So I'm going to add pi over 6. Well, the common denominator between these two is 12. Okay, so the common denominator between negative pi over 4 and pi over 6 is 12. So some people off to the bottom over here might actually have to go 3 pi over 12 and add 2 twelfths each time. So if I add 2 twelfths, this would be negative 1 twelfth. And if I add 2 twelfths, this would be positive 1 twelfth. And if I add 2 twelfths, this would be 3 twelfths. If I add be 5 twelfths. Subtracting 2 twelfths each time, this would be negative 5 twelfths, negative 7 twelfths, negative 9 twelfths, which can be reduced, and then negative 11 twelfths. So this is not a very easy add and subtract. Those of you that are fractionally challenged are going to have a little bit of difficulty with that one. Next, tangent. Tangent is sine over cosine. So the underlying curve that I need to worry about is cosine. Cosine starts off the midline. Every time cosine hits the midline will cause an asymptote. So I have an asymptote at each time cosine hits the midline. Tangent goes high to low. So oh, I'm sorry about that. Tangent goes low to high. Sorry, I almost said that wrong. So tangent goes upward. So tangent goes along the asymptote through the midline, along the asymptote through the midline, along the asymptote through the midline, along the asymptote through the midline. So now, so far, I've dealt with the phase shift and the period length. Now let's talk about the actual midline. The midline now is going to be at negative 2. And because there's no number in front, you're going up 1, down 1. And I always draw in the y-axis. Again, this is one of those things that's in between a positive and a negative. So the y-axis be located right here, in between negative pi over 12 and positive pi over 12. And then that's it. They only wanted you to graph. So again, tangent curve. If you had to describe this one, you're talking about a translation to the left, pi over 4, a translation down 2, and a, we don't actually get into this much, but then we're talking about a horizontal shrink of a third. Next one, I'm going to draw in the midline. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. Pi over 12, or excuse me, pi over 2. So again, we were talking about a phase shift of pi over 2 in the middle there. Period length is normally 2 pi because there's no number being multiplied. That's what it's exactly going to be. And then I take the period length and divide by 4 to get the increments. So the increments in this case would be pi over 2. So that means I'm going to add pi over 2 going to the right and subtract pi over 2. Hold on, I was completely wrong. So whoop, let me erase that. Add pi over 2 going to the right. I said it correctly and then did it incorrectly. Subtract pi over 2 going to the left. It's a secant. Secant is 1 over cosine. So I need to draw in a cosine curve. So cosine curve starts off the midline. And every single time that the cosine curve touches the midline, I'm going to draw in an asymptote. Secant curves go away from the midline. So again, touching and away from the midline. Touching and away from the midline. It never goes towards the midline. It touches the underlying curve and goes away from the midline. So that is a secant curve. Next, describe the midline. The midline there is adding 6. Notice the number at the end there that's being added. And it goes up and down 3. The 3 tells me my vertical stretch. So it goes up to 9 and down to 3. Always draw in, and I always draw in this case it ends up being on an asymptote, but I always draw in the y-axis. So there is a secant curve. This is as hard as I can make it. Notice there's everything that's there. So again, there's a lot of stuff going on here. I'm still going to draw in a midline. I'm still going to draw in the middle. 1, 2, 3, 4. 1, 2, 3, 4. The phase shift, the number that's being added or subtracted, tells me where I'm going to put the middle. Period length. Period length is always 2 pi divided by b. So in this case, the period length is 4 pi. My increment, I take the period length and divide by 4. So every single time I'm going to add and subtract pi for each one of these increments. So if I add pi, I'm going to get 3/2 pi. If I add pi, I'm going to get 5/2 and 7/2 and 9/2. So again, I'm adding 1 pi to the right. I'm going to subtract 1 pi to the left. It's a cosecant curve. Cosecant is 1 over sine. So the underlying curve that I have to make is a cosine curve. Excuse me, a sine curve. And sine curves start on the midline. Every single time, whoops, sorry, I got to go back. I messed up. So hold on. It's a negative underlying curve. So my sine curve needs to go downward. Did you notice that it was a negative sine curve? So I apologize. Every time it crosses the midline, I'm going to draw in an amplitude. Cosecant curves go away from the midline. So it touches the underlying curve and goes away. It touches the underlying curve and goes away along the asymptotes. Next, I need to describe the midline and the amplitude. So the midline is at -1, and the amplitude goes up and down 4. So up 4 and down 4. And then I always draw in the y-axis. The y-axis happens to be right in here, in between the positive and negative pi over 2. That's it. So worksheet, a lot of stuff going on here, a lot of different places where people mess up. Please make sure that you're watching the videos. Please make sure you're coming to the Google Meets. This can be extremely challenging. Let me and Ms. Kensel know if you have any questions, and good luck and be safe.